Welcome to the Stuffler Broadcasting Center. I'm Martha Stuffler, and you and I are going to take a 16-week journey together in your Statistics for Business and Economics course. You're either enrolled under Econ 10 or Management 10. I got a very brief slideshow and wanted to go over some information in Chapter 1 to give you a little bit of an overview about what this class is going to be about. So let me start this slideshow. What is statistics? Well, statistics really is just a way to take a big pile of numbers, organize it so that we're able to describe the data. Well, why in the world do we want to do that? Well, the reason we want to do that is so that we could take something that's unmanageable, make it manageable, so we can make an inference or a judgment or draw a conclusion about the population. Now, there's a couple of words that you should be familiar with. The first one is data. Data is a plural word, which means data are plural. Data are plural. Data are boring. No, they're not boring. Take that back. Data are manageable, and we're going to learn how to manage them in this class, and I hope you'll enjoy using Megastat. Megastat is an Excel add-in that I think is very user-friendly and just very easy to work with. The word statistic, well, that word statistic means a measurement from a sample. So a statistic is just a measurement from a sample. And if you use the word statistics, well, statistics, we could say it's many measurements from a sample, or it's the study of data. So what is statistics? Well, you know, we began statistics back many years ago, 3000 BC in Egypt and Babylonia, when they did a census of the population. Then much later, in the 1700s, came about something known as political arithmetic, when they began with recording mortality rates, birth rates, and deaths, and births and deaths. And then games of chance started to become very popular, and that all led to the discipline that we know as statistics today. In fact, it's kind of interesting if you go back to see how long GDP has been recorded. It's in the United States, for example. The United States has been around since 1776, and even earlier than that, but in the last 200 years, we've only recorded GDP about half of that time. So statistics, as far as keeping the economy and records of our economy, is fairly recent if you think about it being in the last primarily 100 years. Anyway, the course is organized into two parts. The first part, which really is about the first 3 or 4 chapters, is all about collecting statistics, how to organize it, how can we display it or present it, and then, of course, how can we summarize it? Because nobody wants to just look at columns of data or a long column of data. You want to be able to somehow summarize it and organize that data. Then the second part of the class, which is really about 2/3 of the class, is all about inferences. And when we say inferences, as it tells you on this slide, it's talking about estimating values for the population and drawing conclusions and making decisions. But for example, let's say we have this whole huge population, and this population is Toyota drivers. And maybe a parameter, which just means a measurement about this population of Toyota drivers. Maybe we want to measure or know about this particular parameter, this measurement of the population. And since I'm picking on Toyota here, I might as well say how many people in the population have experienced that accelerating gas pedal out of control and taking over the car and had that problem to deal with. So maybe the way to do that is to take a random sample of all from the population of owners of Toyota and survey them. Maybe ask them 5 or 6 questions, and among them would be, have they experienced this problem? And that will allow us to form a statistic based on our sample. In other words, what does the average number say of drivers out of 1,000 Toyota owners randomly selected in the United States that have experienced this acceleration problem with their Toyota. So, a sample is just a subset, as it tells you here, of the population. And the statistic is a measurement that describes the sample. Some of those measurements might include the mean, which is the average, the median, which is the middle value. We'll talk about these later. Something called the standard deviation. Those are typical statistics that describe a sample. And again, populations have parameters. That's their measurements. Statistics have, or samples have statistics like the mean of the sample. A parameter would be the mean or average of the population. Both are means, but one describes the sample, one describes the population. So anyway, we take a sample, and that allows us to take measurements or statistics from our sample to make an inference about the population. Now, why in the world, why don't we just survey the population and get the parameter right off the bat without having to bother with a sample? Well, typically the population is huge. It might be finite, but we consider it infinite if a sample is less than 1/20th of the population. So populations are very large. It can be very costly to sample the population, and it can be very time consuming. I guess it was last year we had our census, our national census, and how many months did that take? There was many workers, very, very costly, and because of that, we only do this, the United States census every 10 years. And then from that, we get information about the population parameters, and then each year we can survey different regions or draw a sample population about the United States population, and then be able to make an inference about what might be happening over time to the U.S. population. Now, Chapter 1 talks about how to classify data. Chapter 1 is pretty easy, and it gives you different categories or way to separate data. There's data that is known as qualitative versus quantitative, categorical versus numerical, and discrete versus continuous. Well, categorical, let me pick that one first. That just means it's names, or what we call nominal data. Categorical would be male, female, freshman, sophomore, junior, senior. Well, we all know what numerical data is. And numerical data really falls into two categories. It can be discrete or continuous. When we say that a variable is discrete, that means it's a whole number. It's countable. Continuous variables have decimal places, like dollars. It's dollars and cents, so they're a continuous variable. A discrete variable might be, the number of times a batter faces the pitcher during a game, the number of innings in a game. Continuous variable would be our age. If you told me your age was 20, it sounds like it's a discrete number, but actually age continues on. There's decimal places with age, so age would be a continuous variable. Qualitative, well, qualitative just means it's not numeric. Qualitative could be things like Likert scales, which might be something like strongly agree, slightly agree, slightly disagree, strongly disagree. That would be qualitative. Quantitative, again, is something that we can put numeric values to or numbers to. Somehow we can quantify it. There's a couple other ways to classify data. One is called cross-sectional, and the other is called time series. Cross-sectional data are the data for one measurement across a spectrum, like, for example, the unemployment rate for every country in the world. That would be a cross-section. You're looking at one variable, but you're looking at many countries. If we wanted to look at the unemployment rate for the 50 highest income countries in the world, then it would be that would be called a cross-sectional study. We might also want to look at, say, the unemployment rate in the United States month by month for the last 36 months. That would be a time series where you're taking one variable across time. Okay, so we've established that data sets are boring. Well, there's good news. There's ways to simplify them and make them easy to examine. The bad news, well, we have to learn the software to be able to do that. Now, let me just go to the next slide. And the next slide, I will have this, I will post this particular PowerPoint in your Chapter 1. And in this PowerPoint series, if you want to review it, it also presents writing reports and how to go through step by step how you would prepare a statistical report. So hopefully you'll find that helpful. So let me skip off of this now and go to Excel. Okay, I'm in Excel now, and I've already brought in a time series. This time series happens to be wait time. And let me keep scrolling down it. This is a series of 100 data elements. This is from your textbook. And this is bank wait times. And I just basically copied it and pasted it into this worksheet. What I'd like to do is show you how to maybe make this a little easier to view. First of all, I've got it in a worksheet. You can't see any lines or grid lines for this data. So let me find it here, but I will show you how to do that. In View, I think it is. Nope. Okay. Page Layout. There it is. Okay, Page Layout. If you click View Grid Lines, then suddenly your grid lines are in the page. You can also click on Print Grid Lines, and that way what it does is it helps you to see the grid lines and differentiate all these numbers a little bit better on the page, and it also prints those grid lines as well for you. Now let's see, what else can I do to this? Well, let's see. How about this one, View? This is what's considered the normal view, where you've got all these blank columns. I think the one I like to look at the most, or the easiest to work with to me, is the page layout view. So let me switch to the page layout view. Whoops, that wasn't the one I wanted. I really wanted page break view. So page break view, now I got to zoom it to 100%. After I get rid of this little message. Page break view just shows me my data again in this one particular column. So what in the world do I want to do with it? Well, I'm going to go to Add-ins. I'm going to click on Megastat. I'm going to go to, well, we've just been talking about the first 3 chapters in your textbook are really devoted to descriptive statistics. And we've got a lot of different ways to describe statistics. So let me just start with to see what Megastat can do for me here. First of all, in this box, which is called descriptive statistics, you've got mean, sample variance, median, minimum, maximum, and range, and all these other choices. And then you've got the, the commands here. But first you've got input range. So all you need to do if you wanted to describe this data is start at the top of the particular box. Oops, let me get back. And highlight that column of data. I got to go all the way down to the bottom. Get all 100 items in there. 100 observations, and I'm going to stop. And so now, Megastat has already put it into a nice complicated form that you and I don't have to worry about what that description is. We can, just by highlighting the column of data, it puts it into the input range, and it's ready to be manipulated with Excel. So I'm going to go ahead and let mean, sample variance, standard deviation, minimum, maximum, and range be checked off here, and just click OK. So right now I have a little bit of descriptive statistics. I have the count telling me there's 100 items. The mean or average is 5.460. The variance and standard deviation are given, and that's something that we'll cover in the next chapter. And then you've got the minimum. Well, the minimum of all those wait times was 0.4. You've also got the maximum. The maximum of all the wait times was 11.6 minutes. And the range, well, the range, you'll also learn about that in the second chapter. The range is the difference between the minimum and the maximum. So the range is 11.6 minus 0.4, which gives you a range of 11.2 minutes. Now let's go back to Megastat, and let's go to something called frequency distribution. So the first choice you have to make when you do frequency distributions is you have to decide, is my data quantitative or is it qualitative? Is it quantitative, which means numeric, or is it qualitative, meaning that it's nominal or categorical? Well, ours is quantitative. So I need to go back to my spreadsheet, because here I've got the choice to do a frequency distribution for quantitative data. It automatically marks histogram, but I'm going to go ahead and hit polygon and ogive. Now, I'm doing this ahead of time, and I'll probably show you this again when we get to chapter 2. But in the meantime, let me just go back to wait time. I guess I'll have to cancel this now before I go back to my wait time page. Let me go back up to the top of the column, just using my scroll bar. Again, I'm going to Megastat. I'm going to frequency distribution. I'm going to quantitative. I'm going to highlight this column all the way down to that 100th measurement, or that 100th observation. Okay. I've marked all three, and in this particular example, I'm just going to do the default, so we're not going to worry about this discussion until the next chapter. I'm just going to do the default, which is histogram, but then I've added polygon and ogive, and I'm going to click OK. And for that data set, and again, here's my output page. The output page is always a separate page at the bottom. I'd show you that, but I limited my screen size here with Camtasia. We've got our descriptive statistics. Then we've got something called the frequency distribution. And the frequency distribution has basically taken that column of 100 data items and broke it down into, let's see, well, 12 categories. It's made 12 categories to make this a lot easier to view. So first of all, it's broken it down. It said the first category, or the first classification, is those wait times that were from 0 to 1 minute, from 1 minute to 2, or greater than 1 and less than 2, up to 2. And then the midpoint of each one of these categories, which is for the first one, 0.5, 1.5, 2.5, and the width of these intervals is 1. And then it took, of those 100 data items, it looked at the frequency. And the frequency, for example, this category from 4 to 5 minutes wait time was the most frequent, with 17 observations that fell into that category. Then this other column is what's called the cumulative frequency. So we had 2 observations from 0 to 1 minute. The next interval was from 1 to 2 minutes, and there were 6 of those. So if you go from 0 to 2, we have 2 items that fell into that those first 2 intervals. And so this is just the cumulative column. Now, I'm having a little problem here trying to keep my screen steady, but here's a display of that data. So that huge data set that was 100 items suddenly looks much more manageable. You've got the wait time going along the bottom from 0 minutes to 1 to 2 to 3 all the way to 12 minutes. And then you've got on this side the percent of the observations that fell. For example, from 4 to 5 minutes, it looks like about, I don't know, 17% of the observations fell within that range. If we pick, say, from 9 minutes to 10 minutes, then there were about 6% of those observations that fell within that range. A frequency polygon, well, you're going to see that again too. Basically, all that does is it takes the histogram, and let me slide that up here for a second. If I made a dot in the middle of each bar, and instead of showing the bars, just showed those dots and connected them, then what I have is a frequency polygon. That's all it is. It's just a little bit different way of displaying the data. And then the last representation, or the last data display, is something called an ogive. And the ogive is just a cumulative frequency distribution. So anyway, I don't mean to overwhelm you here in this first chapter. I'm just trying to show you that, first of all, I know a large column of data or columns of data can be very boring. Absolutely, I agree. But there's easy ways to use Megastat to simplify that data and give it some meaning. For example, if we just go back to our histogram, we can see that very few observations lied with close to 12 minutes, from 11 to 12, and from 0 to 1. But that a vast majority of those seem to fall from, say, 4 minutes to 7 minutes, which we certainly couldn't have told by going through that huge column of data. Particularly, it wasn't even arranged in order. So in fact, let me go back to the data for the heck of it. Going back to the data. That's if Excel will let me do it. There we go. And I'm just going to show you another feature. In fact, now I've got this so narrow that maybe I should give a few more columns. And you can do that by moving this over. There it is. Okay, now, if you click on the Data tab, let me see. Here we go. There's this category or this command called sort. And what you could do is sort the data using this command from A to Z or Z to A. In other words, from ascending or to descending order. So let me click on that. The command could not be completed. Okay, well, let me highlight that data. We'll get it sorted. Highlight the data. All 100 observations again. And then I'm going to click Sort. Now it's asking me sort wait time, sort on values, smallest to largest. Okay, well, let's do it that way. Okay, so there's my wait time sorted smallest to largest. Here's my lowest, 0.4 minutes, and it goes up to, well, let's see what that largest one was. Your screen's not showing you, but it does come out to be 11.6. My screen's just a little bit small for you to see that. But let's go back to this column. It's still highlighted. And let's go back to, I'm back on that Data tab. I'm going to do Sort. This time I'm going to click Z to A. Let's do that. Well, I don't know why, but my system's not wanting to let me do it. I think Camtasia might be competing with Excel at this moment. So, let me go off of it and come back to it. Maybe that'll work. Yeah. Okay. Wait time values, instead of smallest to largest, let's go largest to smallest. And so now you see the column reversed. Anyway, I hope this gives you a little bit of an idea of what we're going to do in this class. As I say, the first few chapters are all allocated or devoted to describing data. And I think Excel makes that very easy and is very user-friendly to work with, and I hope you've seen that. Again, with how easy I was able to take this column of 100 items, generate the output many different ways, the descriptive statistics, the frequency distribution, the histogram, the polygon, and then the ogive. We will be doing this again in the second chapter, and then again the third chapter also relates to describing data or descriptive statistics, and then the fourth chapter I believe is the beginning of probability. And probability, We'll give you a little bit of a challenge, that chapter, and then after that we'll be getting into more inferential statistics. Anyway, I hope you enjoy this course, and I look forward to teaching this class. Please let me know if you have any questions or problems.